Good afternoon everyone. Today, we will be doing tutorial 5 of CZ2007 which is on relational algebra. First, let's recap on some key concepts. In relational algebra, the operands are relations whereas operators are operations on relations. Some core relational algebra that we will come across are union, intersection, selection, projection, products, and joins and renaming. In selection, C is the condition referring to attributes of R2 and the result R1 contains all tuples in R2 satisfying C. An example you see here is Joe menu which selects all tuples in cells with bar by the name of Joe's. Projection uses the pi symbol. L represents the attributes from R2 schema and R1 is created by extracting relevant columns of R2. Note that duplicate tuples are eliminated before the result R1 is returned. The example here illustrates how one can search for beer and price in cells. In natural join, two operations are involved, namely selection and projection. Selection checks equality of all common attributes while projection eliminates duplicate common attributes. For instance, when R1 is joined to R2 on column B, the second and third tuples of R1 joins with the first tuple of R2 to give first and third tuples of the resulting relation. In set difference, R1 and R2 have the same number of columns and data types of respective columns should be the same as well. Not that the resultant relation R3 contains all tuples in R1 and not in R2. The example you see here allows us to find employees that are in the test department but not in the design department. The division operation is useful for expressing queries that include a for all or for every phrase. Informally, R1 divided by R2 contains the parts of tuples of R1 that are associated with every tuple in R2. In this example, to get R1 divided by R2a, we first look for all tuples in R1 with PNO found in R2a. Then we check to see if the corresponding SNO should be added to the result relation. When we examine S1, we observe that the pairs S1P2 and S1P4 exist in R1, so S1 is added to the result relation. However, in the case of S2 and S3, note that the pairs S2P4 and S3P4 do not exist in R1. Hence, S2 and S3 are not added to the result relation. Let's look at another example R1 divided by R2b. In this case, the pairs S1P1, S1P2, and S1P4 exist in R1. Hence, S1 is added to the result relation. The general rule is that all values of SNO in the result relation should have tuples between itself and all entries in R2b. An example of grouping and aggregation that you see here is the selection of sum of B from R2 and grouped by A. In terms of operator precedence, unary operators have the highest precedence, followed by multiplicative operators and additive operators. We shall now look at question 1a. Please press pause at this point if you need time to attempt this question. Here, the selection operator is to select year of publication before 1960 and it is being selected from books that are on loan. When you add the next component of the algebra, you are actually looking for library members who have borrowed books that are published before 1960. Finally, with the projection, this query is to find names of library members who have borrowed books published before 1960. We move on now to question 1b. Please press pause at this point if you need time to attempt this question. This question involves a set difference operator. The set on the left finds IDs of library members who are under age of 21 whereas the set on the right finds IDs of library members who have borrowed one or more books by the author J.K. Rowling. With the set difference, you are actually looking for the IDs of library members who are under age of 21 and have not borrowed a book by the author J.K. Rowling. Now, we will take a look at question 1c. Please press pause at this point if you need time to attempt this question. In question 1c, the left-hand side of the divide operator looks for IDs of library members and serial number of books on loan whereas the right-hand side looks for serial number of books with title of C programming. Together, the divide by operator finds IDs of library members that have borrowed all books with title C programming. When we consider the entire query, we are looking for names of library members that have borrowed all books with title C programming. Next, we move on to question 2a. Please press pause at this point if you need time to attempt this question. First, we identify the relations needed to find the names of professors and that of departments that have fewer than 50 PhD students. These relations are professor and department, respectively. Observe that R2 finds the details of professors who work in departments that have fewer than 50 PhD students. However, what we need is only the names of the professors. Hence, we apply the projection operator on R2. We move on now to question 2b. Please press pause at this point if you need time to attempt this question. Similar to the previous questions, we identify the relations required. In this case, it is the student relation. In particular, we need to make use of GPA in student for finding the lowest GPA. First, we find the lowest GPA and assign it to be min GPA. Then, we find the details of student with lowest GPA. Finally, we do a projection on R2 to get the results. Then, we move on to question 2c. Please press pause at this point if you need time to attempt this question. First, we identify the relations needed to find the names and majors of students which correspond to the relations student and major. We also need the relation course for information regarding database system course. Observe that the relations course and student are not linked. Hence, we need to also consider the enroll relation to establish this link. First, we find details of courses with course titled database system. Then, we look for IDs of students who have taken the database system course. By joining with the student relation, we can look for details, excluding major, of students who have taken the database system course. In order to find details of the major, we have to perform a join with the major relation. Finally, we project on the columns that we need in the final results. We now move on to the last part of question 2. Please press pause at this point if you need time to attempt this question. We need the student relation to identify the IDs, names, and GPAs of the students. The course information from the Civil Engineering Department can be found using course relation. Similar to the previous question, the enroll relation is required to link up student and course. First, we find details of all courses from Civil Engineering Department. Then, the divide by operator is used to find CID, grade, and sectional of students who have taken all courses from Civil Engineering Department. The relation R3 contains details of students who have taken all course from Civil Engineering Department. Finally, projection is used to get the required information into R4. We shall now look at question 3a. Please press pause at this point if you need time to attempt this question. Similar to question 2, we identify the relations required. Here, players relation is used to find the names of the players, whereas results relation allows us to look for details of gold and silver medals. First, we identify the player ID of players who have won at least one gold. Then we find ID of those who won at least one silver. R3 contains the players who won at least one silver and one gold. Finally, we project on R3 to obtain the names of these players. Finally, we take a look at question 3b. Please press pause at this point if you need time to attempt this question. Like the previous question, we make use of relations players and results. First, we identify the player ID of players who have won at least one medal. Then, we look for the player ID of all players, and using the set difference operator, we extract the player ID of players who did not win any medal. Using the projection operator, we then extract the names of these players. We have now come to the end of the tutorial. Thank you very much for your attention.